All right, welcome back. Why is the T-Rex hurt? Because dinosaur. Okay, here we go. I don't know if that one made any sense. Today we're still talking about linear relationships, talking about straight lines, and we're going to talk about two keywords today that you will use a lot. Okay, gradient and vertical intercept. Okay, now sometimes remember the vertical is y, so we call it the y-intercept. You'll need to know these things in gradient. I'll give you an idea here. Normally, we, for some reason, label the y-intercept with C, and the gradient we normally label as M. I'll continue to talk about that. Now, every linear relationship, every straight line has a gradient and a vertical intercept. Okay, they all have it. Now, the gradient is a fancy way to say it's the slope of a line. Again, letter M. And I want you to highlight this formula and remember it because we're going to use it a lot. Your gradient is going to be your vertical rise over your horizontal run. Okay. Very, very simply, I just like to say rise over run. That's my gradient. To find the gradient of the following, all we need to do is find the rise over run. So here I can see that my rise is 1, my run is 1. So that means my gradient is just 1 over 1, which we now know simplifies, or we should know simplifies to 1. Okay, for these ones here, my rise is actually 4 and my run is 2. And so here my rise over run is 4 on 2, which is just 2. And for here, just be careful. All these ones have been in the same units. If they start getting to different units, I need to change them into something that's a little bit more similar. So I'm going to write this as 5 centimeters and 100 centimeters. And so for this one here, my rise is 5 centimeters because that's my from top to bottom in case you kind of missing the point of why it's rise, why that's my rise. So between these 2 points, I calculate my rise and my run. My rise in this case is 5, while my run is in this case 100. Okay, because I'm again converting into the same units. Okay, now this is if they've kind of labeled it and these ones here are not to scale, but sometimes they will do ones that are to scale. And so they'll assume that one spacing means one something. Okay, so for these particular ones here, let's take a look. Now, these ones are also got something special about them. This one here is my run. This one here is my rise. So if I take a look at this, my rise, I want you to think of it, I always go from left to right. So theoretically, this is a negative rise. Okay, so that I'm going from here and I'm not rising, but the opposite of rising is I'm falling 5. And I'm still running across 2. Okay, so in this particular case, my gradient, which is M, is minus 5 over 2. Okay, we also have this other one here, and all you got to do for a lot of the times is just count. So there's my run here, there's my rise here. Let's figure it out. I've got 1, 2, 3, 4, 5, 6, 7, 8. My run is 8, and my rise is 1, 2, 3. And because I am I'm starting from a center point and going down, my rise is minus 3. So for this particular one, my rise over run will be minus 3 on 8. Okay, rise over run. Okay, so whether you have labels on them and you have your distances labeled, or whether they ask you and they say it's to scale and they give you some sort of graphing background, then that's how you can do it. Now, the other one here is your vertical intercept. And it's essentially this vertical intercept is where a line cuts the y-axis, or in other words, it's where x equals to 0. Now, I haven't labeled these, but I'm going to put these in. Let's say, for example, this one here is minus 3. This point here is, let's say, 5. I know it's not to scale, but the idea of these ones here is your y-intercept is just exactly where your line cuts your, I'll draw it in blue. It's where your line cuts your y-axis. So right here. So the way that we call our y-axis is, or y-intercept is the letter C. And so whatever that letter is, that becomes your y-intercept. So you can see here, that our y-intercept here is a +5, whereas over here, our y-intercept is a -3. Okay, we don't really need to know this yet, but this point there, we call that one an x-intercept. It's not as important in this course, but still helpful to know. Okay, in comparison to advanced. Okay, I think that's it. Hopefully that makes sense. They'll give you some examples of questions where you find the y-axis and the intercepts. Oh, sorry, the vertical intercept or the y-intercept and the gradient. They'll ask you to find those. That's how you do it. Enjoy. Nice and short and sweet. I'll catch you on the next one. Bye.